Hello, this is Yik Yang from Yeast System Automation LLC. Today I'll be presenting a wafer probing software proposal. The purpose of this presentation is to propose potential new features for the software of a known good die KGD probing test system used in a wafer fabrication facility, and to delineate reasons for working with Yeast System Automation LLC. Finally, I'll do a demonstration. The proposed features include a runtime wafer map, displaying a wafer map with each die colored according to its test result. Runtime graph, displaying a histogram that shows the bin information of the wafer test. Other statistical plots, such as X versus Y, ANOVA, etc., can also be included. Runtime statistic, displaying number of die tested, yield, bin failures, etc. Lot analysis and notification, analyzing the data collected from the entire lot to look for mask defects and send an email to the responsible engineer. Picture instruction, complementing a text instruction with a picture. Concerns. With all these new features, you must have concerns. What about speed performance? Will the program slow down to a crawl? What about development time? Will it take 10 years to finish the program? The answers are lightning fast and short development time. To optimize the speed of the program, LabVIEW is used for multi-threading programming. For a C-based wafer probing program, you have a flow that looks like this on the slide. First, you initialize the test system. Then, you ask the user to enter test information. For each die on the wafer, the prober would move to a coordinate and touch down. Voltage or current is applied to the die as test condition, and the output is measured from the die. After a die is tested, the data is displayed on the screen and logged into a text file. This is repeated until the testing is completed. Note that steps cannot occur in parallel. They cannot happen at the same time. To optimize speed, LabVIEW multithreading is used. 4 threads will be created. The first thread, C column 1, it is called the user input thread. It does nothing but expect input from user and send commands to other threads. The second thread, C column 2, it is the main thread. It will initialize the system, move the prober, apply voltage current, measure outputs, process data, and send commands to other threads. The third thread, C column 3, it is the display thread. It receives data from the second thread and displays the data on the screen. The fourth thread, C column 4, it receives data from the second thread and writes the data into a text file. It is called the file thread. This is repeated until the testing is completed. Note that each thread can happen in parallel at the same time. By using multi-threading in LabVIEW, test time can be decreased while new features are added. What about development time? It is true that C is an awesome language, but it's not made for test. It allows user low-level control, but the development time is noticeably longer. LabVIEW is a very high-level language, and is made for test. So it is a lot easier to use and faster for a test system development project. I have attached a link that explains the differences between C and LabVIEW. Also, LabVIEW has a lot of pre-made drivers and routines, so there's no need to develop a program from scratch. We all want software with great features, don't we? But why would you use Yeast System Automation LLC? Yeast will put a certified LabVIEW developer on the project, and he has experiences with wafer probing and other technologies. The company guarantees that codes are modular, employs good architecture, are well documented, and can be explained in 15 minutes at high level to anyone who has no programming experiences. enough with the words. Let's do a demonstration. I'll double click on the shortcut of the executable that I created for this demo. First, the user would enter the wafer information. I'll enter the lot code, and the wafer code, and the operator. And then a work instruction pops up that asks the user to hit enter. For this particular instruction, the feature does not seem especially useful. However, for a more complex instruction, a text instruction with the pictures would be so much clearer. After I hit enter, the testing starts. On the upper left-hand corner, you see the information that I entered earlier, the lot code, the wafer code, and the operator. Below that, you see online test statistics such as die tested, yield, etc. Below, you see a histogram that shows the bins that the test results are falling into. You can see that majority of the die fell into bin 1 and 2, and the yield is less than 20%. On the right, you see the wafer map being populated as die are tested. And I just used a random generator to classify each die into 3 bins, and just to show you what I can do and to evaluate is this project feasible in LabVIEW. Thank you. This is it for the presentation. Thank you for your time.